Hi all, I am continuing the series of lecture on heat and mass transfer, the unit of conduction. Already we have seen the composite wall thermal resistance in series, that is hot fluid and cold fluid, having three different material ABC, having all the three different material having the three different thermal conductivity Ka, Kb, Kc, and the interface temperature is T1, T2, T3 and T4, and the heat transfer coefficient is H1 at the entry, H2 at the exit, T infinity 1 at the entry, T infinity 2 at the exit. So this temperature values already we have noticed, and this is the circuit diagram. T infinity 1, T infinity, that is T infinity 2 at the exit, the interface temperature T1, the interface temperature T2, interface temperature T3, interface temperature T4. This we have seen already, and this is the resistance. T infinity to T1, there is a resistor. This is coming under the convection. For the same case T4 to T infinity 2, there is a convection heat transfer coefficient. So this resistance is heat transfer coefficient. So 1 by H1A, 1 by H2A. In between this A, B, C having the conduction. So resistance will be having the conduction, considering the conduction. L by Ka. So Ka, L A is that. So La Kaa. Kb, which is for B material, Lb, Kba for Lc, so Lc divided by Kca, and T infinity 1 minus T infinity 2, and Q which is equal to T infinity 1, T infinity 2, and the value 1 by H1A plus La by Ka, Ua delta T, and 1 by R total thermal is the overall heat transfer coefficient. U will be 1 by H1 plus La by Ka plus Lc by Kc plus Lb by Kc plus 1 by H2. This is for the condition for thermal resistance of composite in series. Considering the parallel arrangement, A, B, C, D having the four material, same like fluid having the convection in the entry, convection at the exit, and La, Lb, Lc will be the temperature of the conduction of material A, B, C, D, and for we have the Lb equal to Lc here, and Aa plus Ac which is equal to Aa plus Ab plus A. From the sketch we can understand 1 by R which is equal to 1 by R1 plus 1 by R2, and 1 by R equal to R1 plus R2 divided by R1 R2. This is mathematical derivation. Let me see the thermal resistance circuit here. Here, as like this is convection, 1 by H1A displaced. This is conduction, and Kb, Kc, Kd is conduction, and Kb and Kc having the parallel connection, so the circuit diagram indicated like this, which is having the conduction L by Ka, Lc by Kc, and the infinitive 1 by R parallel which is equal to 1 by Rb plus 1 by Rc. Already we have seen it, 1 by Rb plus 1 by Rc, Rb into Rc. For the composite wall, now let me see for the composite wall. So no convection boundary is considered here. For the case, two materials are there. You just imagine one material over another material is cylindrically impinged over there. So first material having thermal conductivity K1, second material having thermal conductivity K2, and T1 is the beginning point. On the interface point 2 is T2, end point is T3. Same like from the center point, R1 to the T1 point, R2 to the T2 point, R3 to the T3 point. Already we seen in the derivation that there is thermal resistance for the cylindrical surface will be R1 which is equal to ln of R2 divided by R1 divided by 2 pi KL for the circumferential. For the R2, for the second one thermal resistance will be ln of R3 divided by R2 divided by 2 pi KL, 2 pi K2L, thermal conductivity of second material will be here. Coming to the thermal resistance circuit, T1, Q1, R1, T2 will be at this point, so that is conduction, R2, T3. So total resistance which will be, R total will be R1 plus R2, R total which is equal to ln of R3 by R3 that we have seen here. The same equation we are substituting. Heat transfer will be T1 minus T2 divided by R1 is equal to T2 minus T3 by R2. And which is nothing but R1, R2, we can interface the value. So the total Q will be T1 minus T2 divided by R total. T1 minus T3 divided by ln of R3 by R1 divided by 2 pi KL plus T ln of R3 by R2 2 pi K2L. So this is the thermal resistance and heat transfer equation for the cylindrical surface of composite in connection with, in earlier we had seen the series connection and parallel connection of arrangement and thermal resistance diagram, and we have seen the thermal resistance in series connection also in the diagram. So with this I conclude my lecture. Anything you can see in the future class. Thank you.